chain rule and trig. So, all right, we'll start with a simple one. Up till this point, we've only done derivative of sine x, derivative of cosine x. We haven't had anything inside the trig function, all right, other than x. And this is still chain rule. Like you're still using chain rule in this. If you go, the derivative of sine is cosine times the inside derivative. Well, what's the derivative of x? It's 1, right? So that's what you have to do every time there's not a 1 in there. All right, so the outside function here is sine. So the derivative of sine is cosine of whatever was in there, so 2x, times the inside derivative. What's the derivative of 2x? 2. Okay, now I'm going to show you the mistake that people make. Don't do this. All right? Does not equal cos of 4x. It is not that. Okay? You cannot take this 2 and multiply it by this 2x. This 2 just goes in the front there. Okay? So the actual answer is 2 cos 2x. All right? Don't do that, please. All right, so you can get funky things inside the trig function. You can have stuff like this. Cos of x, x squared plus 2x. Well, not cos of it. That's going to be, it's just cosine of x squared plus 2x. There we go. Okay, so your outside function is cosine. So you start with the outside. The derivative of cosine is negative sine of all that stuff times the inside derivative. What's the derivative of x squared plus 2x? 2x plus 2. Now you can move that to the front if you wanted. You could write I mean, at this point, unless you're going to multiply it out, which I wouldn't, I would just leave it like that. Okay? Depending on what you want to do with it. 3. So this is where you need to understand the notation. How many functions are there here? I don't know. How many are there? I see 2, but is there more? There's 3 of them. Because if you think of it, this is actually this. 1, 2. That's what that means, right? So now you can see 3 functions. You can see the squared, you can see the sine, and you can see the 3x. There's 3 of them there. It's called a nested trig function, if you want. All right? So you start with the outside function. What's the outside function? It's the squared. So the 2 falls down. Take 1 away from it. So I'm left with 1. So I can just write that. You could put in brackets, put the power of 1, but it's kind of redundant. Times. So then if I covered up this 2, I said, okay, what's the derivative of this? You start with the sine first, right? Derivative of sine is cosine of the inside bit, which is 3x. And then you've done that, and you've done the sine. The only thing left is the 3x. What's the derivative of 3x? 3. What can you multiply together? The 2 and the 3. Now, there's double angle identities and all these things that you can use to simplify that. I'm not too worried about that right now. Okay. So we just leave it like that. Is that okay for everybody? All right. How about this one? So what's being squared here? Just the x, right? So it's the same as this. Nobody would write it like this, but like that. So the outermost function is cosine, because the x squared's inside the cosine. Okay? So you start with the derivative of cosine, which is negative sine of x squared times the inside derivative. So what's the derivative of x squared? 2x. So you clean that up and just say negative 2x sine of x squared. So what's the derivative? Okay, this again comes to notation. If the x squared was inside the trig function, I would have written it like this. Okay, so since I didn't write it like this x squared is being multiplied by this. What's cosine of 3? I don't actually care. Some number, who cares? All right, it's a constant though. You care about what? You care about the constant, but you don't have to worry about the constant when you're doing the derivative, right? So I can just go y prime is equal to the constant, which is cos of 3, times the derivative of my function. What's the derivative of x squared? 2x. There's your derivative. Because this is a constant. Is the cosine being squared? No. So the outermost function is cosine. So I do that first. Derivative of cosine is negative sine of all this stuff times. Now you've done the cosine derivative. That function is gone. Now you just have to do the derivative of 3x all squared. What's the derivative of 3x all squared? What rule do I need to use? Power. Okay. So the 2 falls down, right? And I get 2 times 3x to the power of 1. I know, I'm not done yet. That's the other way to do it. I'm not done this yet. Yeah. No, I lost my train of thought. Times the inside derivative. What's the derivative of 3x? 3. So then you can go 3 times 3 is 9, times 2 is 18, times the negative. Oh, what is the x? There we go. Negative 18x sine of 3x all squared. There's one way to do it. You could also do this, because that's being squared. It's like that. And then do the derivative. So it's negative sine of 9x all squared times the inside derivative. The derivative of that is 18x, which is the same as that. There's always like multiple ways to do these things, depending on how things look to you. All right, I got one more to do, and then we're done. So the trig ones can get a little ugly. Cosine of the square root of sine pi x. So I'm going to rewrite this. First of all, we don't like square roots. What do we like? We want exponents. So this is like cosine of sine pi x to the power of a half. Okay, what's my outermost function? Cosine, right? Because this junk is inside the cosine function. So derivative of cosine is negative sine of sine pi x to the power of a half times. So now the cosine is gone. You need to do the derivative of sine pi x to the power of a half. What rule do we need to use? We use chain or power, whatever you want, or general power. Okay, because it has this 1/2 power. So that falls down. Take away 1, so I get that. So now I've done that one. I've done that one. The only thing left is the sine pi x. What's the derivative of sine? Cosine. So now everything's gone except for the pi x. What's the derivative of pi x? Pi. I'm not going to give you one like that on the test. But it's like a function inside of a function inside of a function inside of a function inside of a function. And then you would, if you wanted to clean this up, that would drop down, that would be there. So you're going to get negative pi sine and the cos and there's some identities that you could probably use to simplify that, but I'm not going to, and I'm not going to give you one like that. But you can see the trig functions can get a little crazy because it's easy to have multiple functions inside of each other. Just a couple questions or a few questions. Then we'll do higher order, which will take 2 seconds to do. Page 136, we will do 43 to 63 odd, but not 51, 53, and 59. Yeah, there you go. And I'll quickly do higher order right at the end, which take like 5 minutes to do. No quiz tomorrow because we have a shortened class. It's like everyone's Now we're not gonna.
I don't understand.
From here, right?
So how did I see that?
So you dealt with every function. Put it there. If you want, remember the derivative of the tan function is what? Secant squared. You can use that. We proved it. Oh.